Welcome, everyone, to this week's installment of the Ekahau webinar series. We'll be focusing on troubleshooting this week, and I think it's fitting that we're actually here at HP Discover talking about a short turnaround for deploying a wireless network. And as good as your intentions are in every one of your designs and implementations, users ultimately connect their devices to the Wi-Fi network, and inherently there's situations that you have to perform troubleshooting on, and that's going to be the focus of today's talk.
Yeah, and a quick round of introductions then. We've got myself, Troy, Stu, and Dale, all from the Ekahau team. Myself and Troy, we look after product marketing, and Stu's looking after our community engagement, and then Dale is looking after our amazing sales engineer team. But the guest of today, I'm sure a lot of you already know Francois. He's one of our amazing ECSE instructors, and he's going to be joining us as well. I do feel a little bit outnumbered, I have to say, by Canadians today. I mean, it's probably not a bad thing. Luckily, I get on with all of you three guys pretty well, but yeah. The last webinar I had an English guy with me, Dale, didn't I? But a lot of Canadians today.
Well, you invited us and we said yes. So.
Well, it's an absolute pleasure to have all of you guys here, and I'm really excited for today's webinar. So actually, Francois, why don't I stop sharing and let you carry on, because you can maybe talk us through some of the recent updates we've actually had to one of our ECSE courses.
Yes. Let me. You guys see my screen?
Yep.
Okay. Yeah, so recently we worked on a new troubleshooting class. And so today what I wanted to talk about is a couple of few items, technical items in Wi-Fi that we could look at when we are troubleshooting Wi-Fi, and kind of give you a preview of some of the topics that we talk about during the class. Obviously I don't have. In the class, we talk about it for 4 days. Here we have a few minutes, so I'll go on some of the things fast. But the idea of the class is we go deeper into some of these topics, troubleshooting topics, trying to understand, when Wi-Fi fails, why it fails, and how we can use some of the Ekahau tools to kind of help us troubleshoot those problems. So that's kind of like the idea today of what I want to talk about. And in the course, we have the sections where we talk about common problems. So we call it 9 common factors causing bad Wi-Fi, and we go over each of them to understand how to spot them and what we could do to improve them. So today I wanted to focus on 2 of them a little bit more, so I can show you some of the topics that we talk about, and also I can show you some of the, highlight some of the items that we can do in, validations we can do in AI Pro Online. So I'm going to talk about the interference first, and then the SSID configurations. So when we talk about, Wi-Fi problems, sometimes we have interferences, issues in Wi-Fi. And when we talk about interferences, we could have interferences coming from Wi-Fi systems. So it could be coming from our neighbors, it could be coming from people bringing their own Wi-Fi system, it could be sometimes coming from our own Wi-Fi. Sometimes, the biggest enemy to Wi-Fi is other Wi-Fi, or sometimes our own Wi-Fi. So we take a look at these type of interferences, but we also take a look at non-Wi-Fi interferences. So, Wi-Fi uses unlicensed frequency space. So sometimes we have other technologies, other wireless technologies using the same frequency that can come in the space and interfere with Wi-Fi. So we try to look at both Wi-Fi and non-Wi-Fi interferences when we troubleshoot Wi-Fi problems. And here you have a couple of examples of what these interferences could be. If we talk about Wi-Fi interferences, the one that we often talk about is channel interference. So here you have a view of the 2.4 frequency band. And you can see that in Wi-Fi, we only have 3 non-overlapping channels that we can use on that frequency band due to the amount of spectrum available to us. And that's one of the reasons why we can't use 2.4 in the events venue, like for a big conference, because we would be running out of channels very fast, and we wouldn't have enough airspace to handle all of the traffic. But if you don't configure your access points properly, you could end up in a situation like this, where you have overlap between your different channels. So if I have an AP on channel 3 and another one on channel 6, you can see that they're sharing some of the spectrum. And if these APs are communicating at the same time, that's going to create interference, and that's what we call adjacent channel interference. So that's one thing when we do troubleshooting that we can look at is which channels have been assigned to my APs and try to understand if we have these type of interferences. The other interference we talk about when we talk about channel is co-channel interference, and this one comes more often because sometimes we have to deal with it. If we have to install a lot of APs in the space, no matter what we do, we may have some co-channel interference, and we have to deal with it. So the idea behind understanding, or talking about CCI is understanding when we do have CCI, so be able to recognize when we have CCI, but also being able to understand, is it a problem for my environment? Sometimes we could have a little bit of CCI, but it doesn't really impact the user experience. Other times, it can saturate the channel, and it can be a problem because all of the APs that are on the same channel, they end up sharing that channel. So there's a little analogy that we often talk about when we talk about co-channel interference. We compare the Wi-Fi channel to a road. So on the left-hand side here on the slide, you can see that I have one road, and I only have one entrance to the road. So the only cars that can actually utilize that road are the cars that are coming from that entrance. So the only way I'm going to saturate that road is if I have a lot of cars coming from that single entrance. And that would be, in our analogy to Wi-Fi, that would be the equivalence of having one AP on the channel, right? The AP is the only one using that channel, and only the clients that are connected to that AP are using the channel. So the only way to saturate that channel is to have a lot of clients on that AP. So in this case, we would have no CCI, you only have one AP per channel. In case of CCI, you can take the same road, so the same one-lane road, but now you have multiple entrances. So you can see in this case, I have 4 entrances. And so now I can have cars coming from 4 different directions. And that might be okay, right? If I'm looking at the road at 2 a.m., I don't have a lot of traffic. There's a car coming from different entrances, not too often. So my road is never saturated, and I still have enough road capacity to handle my traffic. But if I look at the same road at 8 a.m. when everyone is trying to go to work, then I may actually get to the saturation of the road faster in this scenario because I'm going to have cars coming from all directions, right? So that's kind of like the same thing with Wi-Fi. If you have CCI, you have multiple APs sharing the same channel. So it might be okay if you don't have a lot of traffic, but if you start adding clients to these APs, and if these clients starts generating some traffic, then you're going to reach the saturation of the channel faster with CCI, right? So when you troubleshoot Wi-Fi, it's important to understand when we have CCI and when it actually becomes a problem. So far, so good? Awesome.
Makes sense to me.
Awesome, thank you. Another topic when we talk to channel, another topic that we talk about when we look at troubleshooting Wi-Fi is the channel width, because the wider your channel will be, first of all, the fewer channels you'll have at your disposal. So the more often you're going to have to use it, and then potentially the more often you're going to have CCI. But also, when you increase the channel of any radio communications, you also increase the noise as a byproduct. So in this case, you can see that if I'm going from a 20 to 80 or from a 80 to from a 40 to 80, I'm doubling my noise every time, which impacts my SNR. And the SNR is one metric that we use in Wi-Fi to measure the quality of our signal. And if we decrease the SNR, it means, well, if we increase our noise, we're decreasing our SNR, which means that we're decreasing our quality of the signal, our signal quality. So that's another point that we have to take into consideration when working with larger channel width. Yes, we're going to have more bandwidth. Yes, we're going to have more speeds, higher data rates, but it might also impact our SNR, our signal quality, which could have also repercussion on the user experience. So we want to understand this when we do troubleshooting to try to see if it's actually the root cause of our problems. If we're talking about more advanced channel problems, sometimes we could have this overlapping BSS interference scenario where you could have 2 APs using a larger channel. So here you can see it on the slide. I have AP1 using an 80 megahertz wide channel, and then I have AP2 using an 80 megahertz wide channels, and they're using the same channel, the same channel here is 36 to 48. But when you use the larger channel in Wi-Fi, you always have to pick one of the 20 megahertz wide channels to be the primary channel, and that primary channel will be used to send all of the management traffic, and it will also be used to kind of assess if a channel is busy. And in this case, in our scenarios, we have two APs using the same 80 megahertz wide channels, but different primary channels. So AP1 is using channel 36 as its primary channel, and AP2 channel 48 as its primary. So they're going to send their management traffic on different channels, and one client will try to sense if a channel is busy. They might actually not detect that a particular channel is busy, and they might transmit at the same time, creating some sort of interference. And that's what we call the OBSS interference. Ideally, if you have multiple APs that are using larger channel width, you would want to use the same primary channels, and that's what we have on the bottom here. In the ideal case, we would configure both APs to have channel 36 as their primary channels, so that they can better understand each other, and they can better work with scheduling their transmission on these channels. So that's also something else that we can look into when we look at troubleshooting, is understanding the channel width that we're using and understanding which primary channels are being used. And talking about this, I want to show you a little demo in AI Pro Online. So I'm going to go in AI Pro Online, and here I have a survey that someone has done for me. I think it's Matt who did this for me. But we have some sort of environment here, and you can see that right now I'm looking at the 4th floor. I'm looking at 5 gigahertz, and right now I'm looking at the signal strength. What I can do here is I can actually change my visualization and select channel interference, and here it's going to tell me if I have any problems with my interferences or not. So it's going to show me my level of CCIs, and then at the top, if I use the inspect tool, I can click in this hallway, for instance, and here I can understand here on the right what I can hear in this specific spot, and you can see that here I can see an AP on channel 100. I can see another AP here on channel 100. So these two APs are using the same channel. They're seeing one another, so they're creating that little bit of CCI that we have here. What I can also do is I can zoom in. So if I zoom in on the floor, and if I zoom in on one AP, you can see that next to my AP circle, which identifies the location of my AP, I have 3 bubbles here that gives me information about the AP radios. So I have the 2.4 radio, the 5 gigahertz radio, and the 6 gigahertz radio. And here, looking at this, I know that this AP has its 5 gigahertz radio on channel 100. So it's going to give me the channel number of that specific AP. If I click on that AP, go back in the select tool and click on that AP, I'm going to have a panel on the right that's going to give me, that's going to give me details about the different radios. And you can see I can drill down even more about which channel is being used, which channel width, right? So if it's 20 megahertz, it's not going to show it to you here. If it's something else, it's going to show it to you here. As you can see, for 6 gigahertz here, I have the channel 5 with the channel width of 160. So I can find out this information just by looking at the floor plan and looking at my APs. Now, before I go back to the slides, I want to go to 6 gigahertz and see what we have there. If I click on 6 gigahertz, you can see that really fast, my map is becoming red, right? And if I look at it in a little bit more details, if I actually hover on the color, it's going to tell me in the legend here at the bottom, it's going to tell me how many APs are on the same channels. You can see that here on this floor plan, sometimes we have 4 or 5 APs on the same channels. And if we analyze go back in my inspect tool, but if I analyze the channels being used here, I can see that they are using 160 megahertz wide channels on 6 gigahertz. And if we look at these two APs, you can see we're using channel 5 and channel 21. So if I go back, I have this little table that I use here that gives me all of the channels for 6 gigahertz. But if I look at the 160 megahertz wide channels, you can see that channel 5 and channel 21, they are part of the same 160 megahertz wide channel. So here we have a prime example of two APs sharing the same channel with two different primary channels. The channel number you see here in Ekahau is the primary channel. This is the channel on which the APs are sending the beacon that Ekahau is actually detecting, right? So here I can understand this looking at the data that I'm seeing in AI Pro Online, and I can, put together a plan to actually improve the configurations of my radios. Here I would probably maybe tune down the channel width, maybe change the primary channels. On 6 gigahertz, we like to use PSC for the preferred scanning channels. So I would probably do some stuff like this to improve the situation there. Are we good with time, Matt? Okay, awesome. Okay, the second item I wanted to talk about is the SSID configurations, because sometimes the way we configure our SSID can actually have a big impact on the user experience in both directions, right? We can make it really good, but we can also make it really bad depending on how we do it. So it could be a cause of bad Wi-Fi. Today we have the discussion about, should we do a single band SSID or multi-band SSID? I know back in the day, we used to have multi-band SSIDs. And then when we wanted to actually steer more devices on 5 gigahertz, we started to do single band SSIDs to kind of force the 5 gigahertz clients to connect on 5 gigahertz. But nowadays with MLO and working on multiple bands, we're like in a scenario where we may want to go back to multi-band SSIDs. So depending on what we're doing, depending on our environment, today it will not be uncommon to see your main SSID being deployed on both 5 and 6 gigahertz, right? So here during the class, we talk a little bit more about the pros and cons of doing single versus multi-band SSIDs. And then the big part of the user experience in Wi-Fi is what the client does. And in Wi-Fi, we know that the client actually takes some very important decision. First, the client decides which AP it connects to, and then it will decide when it wants to roam and which AP it wants to roam to. So we don't really control all of this from the infrastructure side of things, but we can use some technologies to kind of help us improve that experience for the users, as long as we understand how it works and if the clients actually support all of that, all of these additional technologies. So I wanted to talk a little bit more about it here. In class, we have this nice analogy with how an AP will choose an AP, and we talk about how you would choose your best restaurant going through the restaurant apps. It's kind of like the same thing when a client goes into an environment. So let's say this morning, Stu coming out of the elevator and entering the venue space at the conference, he pulled out his phone, and then this phone will, it will detect a whole bunch of AP broadcasting the conference Wi-Fi, and then the phone somehow has to choose which AP they want to connect to. So the Wi-Fi driver of the phone, based on all of the replies that he would have gotten from the APs, it's going to take the decision to say that, okay, I want to connect with AP B. And then at this point, it will exchange some frames to authenticate itself and to actually get access to the Wi-Fi. So all of that is kind of built into the client device. And sometimes that can generate problems based on how you configure your network and your APs. This is a list. I'm not going to go through all of the points, but these are examples of some of the data that could be taken into consideration when the phone is actually selecting the right AP and the right network. And on top of the selection of the network, we also have the roaming, right? And roaming is it's very important, especially nowadays where we're doing more and more real-time applications. Well, look at Troy and Stu, right? They're on Zoom right now, trying to have a conversation with us. So, and you see that, across multiple verticals, you see more and more people on Teams, on Zooms, all of these conferencing apps, but they're not always stationary. Sometimes they take team calls on their phone and they roam around in a factory or, in an office space. So roaming is becoming more and more critical for Wi-Fi. And once again, in the roaming process, the client is taking key decisions. He's deciding when he wants to start the roaming mechanism. the roaming process, and then he decides which AP he wants to roam to. And so sometimes we can have some slow roam events where the client takes a little while to roam, and then if it takes a while to roam, then you could have impact on the user experience, especially when you do real-time applications. In this example, you can see that the Wi-Fi network has been configured with the very basic, and so when a client roams to a new AP, it has to do the whole authentication again. And in this case, the network is configured with .1x authentication, so the client has to do all of the exchange with the radius server. And depending on where your radius server is located and how many of these exchanges are, you can increase the delays of the roaming because you have to redo that authentication every time you roam. Okay, so it overloads the Wi-Fi, but it also overloads the radius server, if you think about it, because if you have like a whole bunch of, let's say, students on the campus roaming around and asking to authenticate every time they roam, you're going to overload your radius server as well. So so it's not the most optimal things we can do. We have a couple of protocols that can help us. Over Wi-Fi, we have something called 802.11r, fast roaming, fast transition, you'll see. And then what happens there is that when the device roams, it optimizes the frame exchanges, and it doesn't redo the entire .1x authentication every time. So as you can see here, like we're going to trim down the amount of frames that we're going to use to do the roaming. So we're going to do a reassociation and an authentication as part of regenerating the encryption keys that we will need to encrypt the data in just 4 frames. So we're kind of saving some frames, and we are not redoing the entire authentication again. And the APs pretty much exchange some security information about the clients to make it work. So that allows us to reduce the roaming delays quite a bit to improve that roaming experience, and you're not overloading your radius server. So there's 2 flavors of 11R that we talk about during the course. We have the over the air and we have the over DS, and it's just a way that the information is communicating between the APs and the clients. They can go either over the air or they can go over the DS, which means over the LAN. And depending on how you configure things, you could have different problems appearing. With 11R, one problem that we may have also is the support of the client. If the client doesn't support it, then sometimes you can have problems as well. So once again, understanding what the client can do can be a very good asset to doing Wi-Fi troubleshooting. Here you have a little example of what it would take to roam without 11R. So in this case, it took 370 milliseconds, and then after we enabled 11R, it took 50 milliseconds. So you can see it's a pretty big jump here in the roaming delays. 11K is another protocol that we can configure on our SSIDs, and 11K will help the client discover new APs. And what will happen is the client, as it connects, usually it happens right after the association, but when the client connects to the AP, it will ask the AP, can you tell me more about your neighbors? And then the AP will send what we call a neighbor report to the client. And so the client will know that around that AP, we have other APs on different channels, and the client will have information about these channels. So when the client is ready to roam, instead of just scanning everything to find a new AP, it will just scan those specific channels first, because there's a great chance that the next AP he wants to roam to is part of this channel. So it can optimize the AP discovery when the client is ready to roam. And then 11V is another protocol that we can configure on our SSIDs. And this one is a protocol that the infrastructure can use to provide advice to the clients. And so the APs could tell the client, you know what, you will probably be better off connecting to that other APs on this channel. And it doesn't really force the client to do it, but it advises the client, and the client can take that data, act on it, or it can just ignore it, depending on how the client behaves. At the end of the day, it's always the client that decides what to do. But it's important to understand, if we're using it, if the clients are seeing it, if the clients are taking action on it, or if not, and then also if the client supports it. So it's another one of these features that could be useful, but can also cause issues on our Wi-Fi networks.
Hey Francois, just before you jump to
Yeah,
the next slide, I just wanted to point out one quick thing here. Can you see where it says like the disassociation imminent and then like the flag set to 1?
yeah.
Yeah, so
Here.
yeah.
Yeah. Sorry, I clicked.
Yeah, there. Um, I don't want to say too much about it now, but I just want to point out that's a part of like 11v when the infrastructure send that to the client device. I'm going to come back to that in a few moments time. But I just wanted to point that out before we moved over to the next thing. But no, thank you for that theory and demos, Francois. That was very good. I can see people in the chat really enjoying your, especially the CCI road analogy. Apparently, quite a few people have already used that one in the past as well.
Thank you. Appreciate that. Well, thank you for your time. I hope I was on time. I know you guys have a lot you want to talk about today. But if you want to hear more about this, you should take a look at the ECAC troubleshooting class. It's a very collaborative class as well. So you'll get to exchange a lot with your peers and with the trainer. So take a look at this if you want to dip deeper into all of these different topics.
Thank you, Francois. I will steal back the screen share from you now. And we have a new Ekahau feature that we want to talk to you about. But before we reveal the feature to you, I just want to tell you a little story first. And it's of when I did a warehouse going back a few years ago. So we was engaged to go and do a design for the warehouse. We went there, we did our survey, we did our pre-design stuff, we built it out in our model, simulated the materials and placed all of our access points. We provided the data to the customer. They were happy with it. We assisted in the deployment of the network, so configuring the access points, the antennas, etc., etc. We went back after everything was installed. We did a validation survey. Everything looked good from a coverage perspective. We didn't have any channel interference, no non-Wi-Fi interference, and all of our devices, they were working really well. So like things like iPhones, laptops, iPads, etc., etc. The customers' corporate machines, like their laptops and their mobile phones, they were all working great. However, there was one specific type of device that wasn't working, or was getting complaints that they were having issues. And it just so happened to be is that the scanners that they were using in the environment, they kept getting randomly disconnected. So even if the user was like kind of underneath an access point, scanning some of the inventory, it would randomly get disconnected. And the thing about that was very frustrating for the user is it would make a very loud beeping noise, and it would pretty much lose the um, data that they were scanning. So it was very disruptive for the user. And like I said, we did the design, the deployment, the validation, configuration was good, coverage was good. We had no real obvious signs of what could be causing these devices to have issues. And I don't know if any of you on the call today have ever tried to look up a data sheet for a client device to try and find out the information of what the device can do for in terms of its Wi-Fi capabilities. So sometimes you can look up a data sheet and you can find lots of information like what the standards it supports, what channels it supports, what protocols it supports, just like what Francois was telling you about, etc., etc. And then sometimes you can look up a data sheet for a client device and it can just say, yeah, this does Wi-Fi. And you're like, great. What kind of Wi-Fi does it do? So yeah, we was in a little bit of a pickle. So we was trying to figure out what was going on, and we were speaking to the support team and things like that. And we had to end up doing we needed to do a wireless packet capture so we could really truly understand like what was going on with the device and what it could do. So I don't know if you've done a wireless packet capture before, what is involved to do a wireless packet capture, to do the protocol analysis. Well, you need to have, first of all, tools and software that you can then use to capture wireless frames. So I had my Ekahau Sidekick, of course, and the Analyzer application, so I can do that. And the nice thing about using your Sidekick, Sidekick 1 or Sidekick 2, is that there's multiple radios inside of the Sidekick. So that means you can simultaneously capture on multiple channels at the same time, which is really handy if you need to ever capture things like roaming events, or if the particular AP that and the client device that you're troubleshooting has multiple radios, you can set the Sidekick to scan one of the radios on 2.4, one on 5, and one on 6 gigahertz. So let me talk you through the steps required to do this kind of analysis that we needed to do. So first of all, the step one is I needed to verify what channels the scanner was using, and then make sure that the client device was also going to be connecting using the same channel. And then we can then start doing the wireless packet capture. And once we've done the wireless packet capture, we can then share the capture to start, reviewing the data. And once we have got it on our machine, we can then open it in our protocol analyzer of choice. I think probably one of the most popular ones is Wireshark. So again, let me show you what those kind of steps would look like using the tools. So we have a feature in our Ekahau Analyzer application called the network overview. So here I can see my access point, what frequency and what channels they're using. So on 5, it was using channel 157, and on 6 gigahertz, I think I'm using channel 21. So once I have this information, which is really important to know, I can then go to the capture feature inside of here, and I can set the channels to scan on for the sidekick. I just do a 30-second packet capture now. And then what I can then do is I share it to my laptop. I open up the frame, the Wireshark. In Wireshark, I open up the capture I just did, and you can see in 30 seconds, I had nearly 17,500 frames to go through and analyze, which is quite a lot. So it does kind of require you to have a understanding of what you want to look for. And I was actually, in particular, looking for the association request frame, because that's where the device is going to advertise what it's capable of doing. And I can then start going through all of the decodes, and I can look for those features and parameters that, Francois was talking about. Like, does it support 11R KV? What channels does it support? How many spatial streams does the client device support, etc., etc. So once I had done that, what I had realized for the scanner in the warehouse environment is that it actually didn't support 802.11b. So in one of the fields here where it says 802, I think it was a BSS transition. I think it goes past it just there. You missed it, but it's fine. What I realized is that the scanner didn't support 802.11b, but the wireless network was configured to use 802.11b. And what the scanners didn't like was being sent from the infrastructure that disassociation imminent frame, because the scanners were quite happily being connected at a lower signal strength because they're only sending tiny bits of data. So they were quite happy at, minus 70, minus 72, even minus 75. But the infrastructure was trying to take that decision back and be like, hey, maybe you should go and move and connect to another one of my neighboring access points, and you'd have a better time. So from looking at that, I was able to understand that because the device didn't support 11V, but what if I switch off 11V on the network? Will that improve the performance for the scanners? And it just so happened that switching off 11V on the network fixed all of the issues we were having with those scanners. So we was able to go home and everything was working great. No issues since we did that. But you might be thinking, why is it that I was specifically looking for the association request frame? Is there any other frames that we might have been able to get some of this information from? And I want to show you the difference between the probe request and the association request for the same device in that same capture. Now, on the left-hand side here, on the probe request, you can see I'm looking at the details about how many spatial streams this client device is saying or advertising that it supports. And you can see it says it's got the capabilities to do one spatial stream, one transmit, one receive, which is interesting because if I then look at the association request for the exact same device and we look at the same fields here, I can see that the details about the number of spatial streams that the device supports, it now says it supports 2 spatial streams. Well, why do client devices lie sometimes? I don't really know why it's not advertising all of its capabilities, but that is why it's important that we capture the association request frame to truly understand what the device is capable of doing. And Troy is going to come back to why the association request frame is quite important later on as we get to our new feature. But first, we're going to launch a quick poll question. So Troy, if you don't mind doing the honors of reading it out whilst I launch it.
Yeah, so it was really interesting to hear Matt describe his troubleshooting scenario here. So I'm not sure if everyone has a Matt Starling available to them. So I'm curious for everyone on the call, How comfortable are you performing a wireless packet capture, analyzing those 17,000 frames, looking for that needle in the haystack, finding that one nugget of information that you need to troubleshoot the issue that you're having on the network, right? So are you very comfortable with this? Are you a packet wizard where you regularly look at Wireshark decodes? Are you somewhat comfortable with this? Have you sat through a previous ECSE troubleshooting class where you've been exposed to some of the Wireshark configurations and customizations with coloring rules to make it a little bit easier to sort? Or is packet capture something new and foreign to you and you wouldn't be comfortable at all opening up a PCAP natively?
Yeah,
So let us know in the poll questions.
I have to say I was very fortunate that I'd recently come off the back of like a few of like ECSE training sessions where we had spent a fair amount of time going through like Wireshark and Decode, so I knew what to look for, all the different filters and things like that as well, to be able to go and understand what I needed to go and look for. I think without that training, I personally wouldn't have felt that comfortable trying to even do that, or even where to start. That I needed to capture the association request frame. So yeah, very interesting results. Let me end the poll and share the results with everybody, because I feel like everyone is kind of in the same boat as what I was at the time. Like I was somewhat, like maybe somewhat comfortable with it, but I kind of understood it, but I didn't really do it that often. Maybe I've like watched some videos, read some things about it, but actually doing it in the real world to try and analyze and find the problem was quite a challenging, thing for me. So I can share the sentiment with all of our viewers today, agreeing, that most people are not that comfortable with it. They understand it, but barely do it. So yeah, interesting. Let me stop sharing the poll results, and Troy, I will stop sharing because I think you're going to take over for now.
Perfect. So what we want to talk about today is a new feature that's being released for the Analyzer tool available on iOS. So leveraging the information we can read from the Sidekick 2, we have the client analysis tool that allows you to quickly identify the root cause of issues that you'll see on your network. So instead of going through Matt's 42-step process to eventually drill down into a Wireshark capture after he's analyzed all the wireless networks that are around him, sift through all the frames that he's captured, apply coloring rules and configuration settings to Wireshark, ask Peter McKenzie 5 questions about what he should be looking for, how to organize and sort things, right? What if there was an easier and simpler way to gather that same information, taking all that complexity out of it, right? Now, you still have access to a lot of the Ekahau tools that allow you to accomplish those tasks, right? But there's a simpler way that we're going to talk about to collect that and identify the root cause information, right? So to make sure everyone's aware of some of the tools that we already have available for you inside the Analyzer app to easily identify and pinpoint, narrow down, zoom in on some of those issues, we do have Speedtest integration built into the Analyzer app. So I'm sure most people on this call are familiar with using Speedtest, where we can send a test in downstream direction and the upstream direction. We can report on the latency during that test. But if you run that speed test through the Analyzer app, while you're performing that speed test test point, you're also able to look at the raw RF spectrum, right? So getting insight and visibility into what's happening on layer 1 can give you tremendous insight into what could be causing the problem. As an example, at HP Discover here, the showroom floor is running on 6 gigahertz using 80 megahertz wide channels, but there's also several showroom areas where they're doing regular sessions where they're filming and recording the content so they can preserve that and replay that at later events or on other webinars. But the cameras used to record some of these videos, they're transmitting on 6 gigahertz. So what we've taken for granted for a couple of years now, clean, untouched spectrum on 6 gigahertz, where we could really rip through speeds and set packet blasting records. We're seeing video cameras taking up that space, jamming it with high utilization transmissions, which is preventing Wi-Fi from using that channel, right? It's such a problem here at the event that we've actually, or the network operating team or network operations center has excluded the four 20 megahertz wide channels around PSC channel 101. So it's been excluded from the channel plan to avoid that interference. But you'd see things like that looking at the raw RF spectrum during a speed test, right? Also, within the Analyzer app, we have the ability to scan all the wireless networks that are out and around you. You can see what APs are advertising what wireless networks, information like the SSID, the amendments that they support, the minimum basic rates that they're configured to allow, what security settings they have, right? So if you're security conscious and you want to reduce risk to your organization, you would be very mindful to any access points that are part of your setup if they're advertising weak or unsecure protocols, right? You never want to be the one caught running a web network these days, and you may be concerned if you see some APs configured to run in transition mode, running both WPA2 and WPA3 at the same time. While it's allowed, and there's a lot of support for that deployment, there are certain security risks that are introduced whenever you run in transition mode. So you may want to adopt or buy into a fully WPA3 network, which could increase the number of SSIDs that you end up deploying, which then ties back to what Francois was identifying is the pendulum swinging conversation of, do you have single band SSIDs or multi-band SSIDs, right? So there's also an airtime consideration, but as well as a security consideration. And then the thing that we want to talk about now and focus on is the client analysis capabilities that we will be adding to the Analyzer app itself, right? So when you launch Analyzer, you'll have the ability to dive into the client analysis tool. You'll pop that up. It'll look like a screen that you see here. And what's going to happen is you can simply move your device close to a sidekick. And when your device comes within range of the sidekick, you'll see your client device float to the top of the screen, right? So based on signal strength, RSSI, the proximity of your client device to the sidekick itself, you'll see that it's close by your sidekick. And then you can click and drill down into that client and analyze what the capabilities are of that client itself. Okay. We also support different views of that if there's different information that you'd like to see with respect to that client. So again, it's that sorted list, but different information bubbles up to the top. So just across the upper right hand corner, you can toggle between the two different views by clicking on those two different display buttons in the upper right hand corner. Right. So now if we run a little demo here, and what I could do is I could show you, I have a sidekick here right beside me. Right? And if I was troubleshooting the performance connectivity of my own iPhone, in case I was having trouble connecting to the conference network here, I would just bring it close to my sidekick, right? Or we have a little video here that you can watch, right? Representing the same thing. You simply bring the client device that you're trying to isolate and troubleshoot, bring it close to your sidekick. That client device will automatically be detected as the sidekick scans all the channels, looking for all the clients around you. In fact, running this application at the HP Discover conference here, earlier in the week, we were able to discover a list of well over 2,000 clients out and around us, right? In the display that you see on the screen, you'll get a list of the SSID that client's connected to, its BS or its MAC address of the client, which will help you filter and select the clients that you want to zoom in and focus on. So once you've identified that client, you can drill down into it and see what it's doing. So there in the screen, you'd see where we click on the client analysis tool. In the upper right-hand corner here, you can see how we can toggle between the two displays. That may make it easier if you find the client that you're interested in focusing on. And when we zoom in and drill down into that client, we see information coming from the client perspective. So the network overview feature that we've had in there for a while, that allows us to see things from the access points perspective, what's being advertised from the APs themselves. Now we're focusing on what's coming from the clients. So in this screen here on the left-hand side, we can see that and confirm that this is the device that was close to our sidekick. We can see what the client MAC address is, right? So if you have access to the client, you can go into its network settings, whatever supplicant tool that's available on that device, confirm what that MAC address is, right? A lot of client devices are using MAC address randomization, right? So you can double check that way that it's the actual address that you want to focus on. We see the signal strength reflecting the proximity or the closeness to the sidekick to itself. You can double check that that client's connected to the SSID, that you're in fact looking at the client that you're hoping to troubleshoot, and confirm again that it's connected to an access point or the BSSID of that access point. This gives you a few different insights, right? One of the things that we've noticed here, so we have a massive showroom floor at HP Discover, and as everyone comes into the showroom floor, they all walk in through the same entrance. And as they walk through the same entrance, Francois already explained earlier about how clients have to make a decision which radio do they connect to as they walk into a big environment like this. Most client devices, when they sort through their list and run their algorithm for deciding which radio to connect to, they'll choose the same access point. And we confirm that this is actually what's happening on the showroom floor. So in the network operations centers, when we get a list of the access points that have the highest number of access points, it is the APs really close to the showroom entrance. Those are the ones that are heavily loaded. And then they're leaving it up to the clients to leverage their natural roaming behaviors that as they walk deeper into the showroom floor, we'll see them roam. But looking at the client analysis tool, we can quickly see, is our client device, is it connected to the AP that we expect right above our heads? Or is it a sticky client stuck to an AP at the showroom entrance or at the entrance of your building or at the start of that long corridor or hallway that you're walking down before walking into your hotel room or into the classroom in your education environment, right? On the right-hand side, we see some other information about what channel we're on, what the relative channel interference is. We can confirm if the client's using the right channel width, right, which gives us some insight into the capabilities of that client, or maybe we've misconfigured our entire access point group or just one of our access points. So it's not using the right channel width that we're looking for. Double check to make sure that we're compliant with our organization's security posture, right? We don't want to have a misconfigured access point network or have a client connecting on an unsecure encryption protocol. One great thing that we've just added to Wi-Fi in the introduction of 6 gigahertz is the mandatory support for management frame protection, right? For the longest time, Wi-Fi networks have always been vulnerable to people spoofing deauthentication frames. And the only protection that we have against that is to enable management frame protection, right? So if you're vulnerable to that risk or if you want to mitigate it, that's a feature that you want to make sure that you have turned on your network. But as you turn it on, you want to make sure that all of your client devices can support that capability as well, right? So here we can see if the client device is capable of supporting management frame protection or that 802.11w feature, confirming that we're optimizing our airtime, that we've disabled those lower mandatory data rates, and that we're getting good coverage from our primary access points, as well as secondary coverage, so that as we move away from the access point, we'll be in a good situation to roam and transition to the next access point as we walk up and down the showroom floor, checking out the various exhibits as an example. Okay. There are some key performance indicators, right? So if you click on the little information bubble, when you launch this app, you can get some more insights, some more explanation about what each one of these features does, so you can better understand the information that you're looking at, right? So you can quickly walk through that as you leverage the app, right? And if you scroll down, right, if you want to harness the power of Matt Starling, we do have an expert mode that you can look at where you get a lot more detailed information about the number of frames sorted into different categories, right? So sort them into the number of frames that are being sent from the AP down to the client, or in the opposite direction, upstream traffic from the client up to the access point. This gives you some insight. Is traffic symmetric or asymmetric? Are you a consumer or are you a producer of content? An example, which could change based on the venue that you're looking at, right? A lot of people from HP Discover are sending in social media posts, posting about selfies with various product managers, videos of new products that they're seeing, access points that have been submerged inside an aquarium. You can also see the number of control data and management frames, right? And this can give you an insight into how busy your network is, right? If you have a network that, as an example, has a very low rate of data frames, but a very high ratio of management frames, that could just be an example of a network that's not very used, right? There's not a lot of traffic being sent upstream or downstream, and you're seeing a lot of that management information simply from beacons being sent by the access point, right? You could also be in a situation where you see a very large number of RTS, CTS frames, right? Which is a classic technique that you can use to identify or resolve a hidden node problem. right? So that's where two clients aren't able to hear each other, but they can both talk to an access point. Now, really, this is a fundamental indicator of a design problem, right? So you probably want to revisit your design in Ekahau AI Pro, see if you can reposition access points, move things around to resolve that issue so that you don't recreate that situation. But in the meantime, you can turn on RTS CTS as an identifier that if you see throughput increase after turning on RTS CTS, that's a probably good sign that you have a hidden node problem in your network, right? So the fact that you're adding overhead from those frames and your throughput goes up, you're avoiding collisions, retransmissions, and seeing increased throughput. So you can see that that's enabled. Now, some vendors have this feature turned on by default. Others have it left off by default. Other vendors will dynamically turn it on based on the size of the frame that they're transmitting, right? So larger frames, there's a greater likelihood that those frames take a little bit longer to hurl through the airwaves. There's a higher risk of collisions. So if the frame is sufficiently large, they'll dynamically enable those features, right? So you get some insight into whether or not those frames are being used, right? So that's some of the information that you can see as part of the expert mode, right? And then as Matt was pointing out earlier, there is some information that you can only capture during the initial connection sequence to an access point, right? So as clients transition through the finite state machine, as they go through the authentication, association, and then turn on whatever 802.1x or the jump straight into the four-way handshake, depending on what's configured, there's certain key elements that are presented in those association request frames, right? So we do have a mode that if you, in your troubleshooting scenario, that if you turn off the Wi-Fi card on your particular device and re-enable the Wi-Fi connection so that we can then capture, while we're focused on that channel for that client, we'll capture that association request frame and then process the information that we can learn from that one specific all-revealing frame. That's extra information that we can then present to you inside the client analysis tool. So that's just one extra step that you need to go through. So again, instead of the 42-step process that Matt Starling can do, right? And you need to be fairly well versed, honestly, in Wi-Fi to go through all those steps and understand what's going on. This is another option that you have in your tool belt that you can simply, with a few clicks of a button and toggling Wi-Fi on and off, get quick access and visibility into the capabilities of your clients. Right?
Yeah, I mean,
and so, go ahead, Matt.
no, but I'm just so excited to see it in action, Troy, from the demo. This has been great. I mean, I've been really excited to talk to people more about this feature. I know exactly how much it's going to be helping people as well. So yeah, I think like from a troubleshooting perspective, this is going to help so much because we do have like a client connectivity KPIs as well, so we can show you if your client device is currently connected to the strongest associated access point nearby. We can also tell you things like what is the current actual data frame speeds that's being sent between the client device to the access point, but also even show you like what retry percentage you have as well between client device and access points. If you're seeing lots of retry frames, that could be a real key indication that you've got a problem with your network as well. But this isn't just a great tool for troubleshooting. It's also a really amazing new feature that will help you design your networks in a way that is going to work for your client devices. So like if you really wanted to understand how some of your client devices are working, and you could try and look up those data sheets or going through that 40-step process to go and do the packet capture and review in Wireshark, now you can just simply go and get the CEO's laptop and their phone, bring it close to the Sidekick, and now all of a sudden you understand exactly what it's capable of doing. So when you're configuring the access point in the CEO's office, you can make sure that the network is going to be configured in a way that it's going to work flawlessly with the CEO's phone and phone and laptop and other devices that you need to understand as well. And also it gives you a great understanding of like what devices are in and around you in your space. So from a security perspective, it gives you a real clear picture of some of the devices. Maybe there's some things there that shouldn't be that you can go and find as well. So yeah, I'm very excited to talk about this feature and show all of you. I think you can see from the people in the chat, they're quite excited about it as well.
Yeah, the security thing is a really interesting point as well. If you happen to work in one of those three-letter agency organizations where they really limit the number of Wi-Fi devices that should be present in that environment, or if you're at a facility that happens to have a lot of steel bars where there shouldn't be a lot of Wi-Fi devices on site, running tools like this just to quickly scan and see, are there any Wi-Fi clients in and around our environment, inside our walls, that shouldn't be or not authorized to be there, right? So not only troubleshooting, but also great insights to design, but also give you some security awareness, what's happening inside the walls of your building.
Yeah. And I think, Francois, you might have a good way of being able to kind of keep some of this information, right?
Yes, yes. So yeah, me and my team, we built this little client database tool, kind of taking over what Mike Albano has done in the past, and bringing up to like trying to adding some features so we could have like one kind of Wi-Fi client database somewhere available out there that everyone can use for free. And we've kind of used different sources to populate the database. We've used Mike database. We've used information from the Wi-Fi Alliance, but sometimes some of these client information is missing. So if we're able to also take data from what people are doing in the field, I think it can make the database even better. So today we have like a manual way to add data into the website. You can go on the website, create an account, and then you can upload the data manually. But maybe in the future, we can work with Ekahau to have some sort of automatic way to send the data to the database so everyone can benefit from it in a more convenient way. Yeah, I really like the new feature. It made me think. I was doing troubleshooting the other day where I noticed that they had a lot of broadcast traffic that were relayed by the APs, but I had to do packet capture to do this. Here, maybe I would have seen, at top of the list, a lot of traffic from one specific client. So I think it's going to help people usually with troubleshooting. It's making the analysis a little bit easier, like you mentioned. Yeah.
Yeah, I couldn't agree more. And then hopefully in the future we'll have a way of sending this information to what's already a great database of information too. And yeah, if you've enjoyed the content today, this is kind of just a bit of a snippet of what we cover in our ECSE troubleshooting course. So if you'd like to find out more, you're welcome to head to the website or scan that QR code, and you can see a list of the upcoming schedule we've got planned for the troubleshooting course. Just been completely revamped, and the courses are delivered in multiple different languages across multiple different time zones. We offer predominantly virtual classes. However, sometimes we do some in-person classes, so keep an eye out for that. And yeah, good luck finding a new class. One other quick thing to mention today as well, since there was a new feature release, you might have seen if you logged into Ekahau Cloud, is for AI Pro Online, we now have custom reporting available to you. We're not going to dive too deep into it today on this webinar. Actually, on the next webinar that we're going to be doing it in July, we're going to be bringing in Vlad, who's our product director for AI Pro Online, and he's going to talk us through some of the different ways that we can do custom reporting with the new features in AI Pro Online. But if you want to give it a try yourself, have a login, and we've got a few different templates in there for you to try out, or you can go and create your own one from scratch as well. And you can build out your own personal custom report now in Ekahau AI Pro Online.
I think it's always been very easy for you just to hit a one-click button and generate a canned or a stock report. But the real value add to professionals who are working in the Wi-Fi space is to come up with your design and then tell that story and provide the heat maps and the actions and the data sets that back up that story. If you're approached for a troubleshooting engagement and you come up with your executive summary summarizing the issues and resolutions that you recommend, you need to include the data that's specific to that story that backs up what you're talking about, right? And it's sad to hear most people only read the first couple of pages, that executive summary. But if they read further, you want to include the information that helps justify and back up why you position the recommendations that you did. And this customization allows you to tell that story.
Yeah. Great, thank you, Troy. So, Stu, Dale, I know you've been furiously replying to people in the Q&A and monitoring the chat. I did mark one question to answer live, but Dale or Stu, was there anything else that you wanted to throw over first?
Yeah, one question that was asked is, obviously with the client analysis, we're collecting a lot of frames over the air. And a question that was asked, I think it's a pretty good question. What's a good indication if you're troubleshooting a client that it's a sticky client? based off of that detail that we gather, what's a good indication with
Uh,
client analysis?
That is a great question. And Troy, I'm just gonna steal the share back from you for 1 second.
Yeah,
Place
for
can't
sure.
share. Okay. So I want to show you this screen. So basically we have this client connectivity KPIs. What this is actually showing you is the association from the client to the access point, and it will tell you if the client device is associated to the strongest possible access point. And if it's not, one of the reasons why it might not be is because it's clinging on to that access point from really far away. And a reason for that could be because some of the low data rates are enabled. So this would be a good indication if you see that a client device is associated to not the strongest possible BSS or access point, and you have low data rates enabled. That could be a reason why you're seeing in your environment like this sticky client issue, and you're maybe noticing that the average data rate and throughput speeds for users is below what you would expect it to be in these areas because of the sticky client sending frames at a lower data rate, and then also slowing the Wi-Fi down for other client devices that are around in that area as well. So this is a really good way to be able to identify and indicate that. So you can see also here the retry rates as well. So it's a really good indication to be able to see the way that the client device is actually performing on the network from just with your Sidekick and Analyzer application. So the amount of things that you can do now with the Analyzer app and Sidekick is pretty phenomenal now. The insights you get into your way your network's configured, the layer one spectrum, your internet throughput speeds, and now also how your client devices are working on the network is pretty robust now. And that is a great way to uh, be able to have a look at what's going on in your Wi-Fi. And there was a question from Larry that I marked as I wanted to answer live. So asking if we do collect the association request and also the reassociation request frame to identify those features, or both. So yes, we will be capturing the association request frame or any of the frames that can populate those fields. So what will happen when you first try this out for yourselves? And a lot of people are asking when this will be available. It will be available very soon. I would hate to commit to a date, but I would say very soon, before the end of the summer, you'll be able to play around with this feature yourselves. When you do get access to it and you fire it up for the first time, when you click on a device, what you will see is you might not see some of those fields populate in the client capabilities because you will need to generate the association request frame by either disconnecting, turning Wi-Fi off and turning Wi-Fi on again, and then or reassociating in some way. So you'll still see a bunch of information, and we can collect a lot of information. But once we get the other frames, we will then populate that information too. And we will have information in there to like guide you to say that, hey, if you want to see this information, you need to try doing this to try and guide you through those steps. Dale, Stu, any other questions?
The questions are all cleared. I guess one that came up, I did answer it, but can you just kind of recap once this is available, who can access this? How do they go about accessing this feature?
Sure. So this will be available to anybody that has a current Ekahau Connect subscription. So you just need to have access to our mobile application. So this isn't an extra paid for feature. It's just a part of your current subscription that you're paying for now.
Awesome. Thanks, Matt.
Stu.
And also for those folks actually wondering how many clients the actually tool can see, well, as long as the Sidekick is out there and hearing things around you, we've actually peaked out at about 2K of clients, believe it or not, on opening day of the show. And that's impressive for the app. And so right now, beside me, you can't see my screen, but I'm seeing about 860 clients right now and 883 BSS. So that's actually pretty impressive that we can actually see that. And that's really showing you kind of the power of the Sidekick too, and seeing that kind of level of detail.
Yeah. Yeah, the level of insight that you're able to get now from your mobile device connected to the Sidekick is just insane. Well, if there's no other further questions, a big thank you to Francois for joining us today to cover the troubleshooting theory and some nice demos, and to the rest of the Ekahau gang that are here as well. Dale, Stu, Troy, thank you for today, and the rest of the Ekahau marketing team. But big thank you to all our amazing webinar guests for showing up, and hopefully you've enjoyed some of the things you saw today, and then looking forward to trying out the new features. I did see people asking about the t-shirts. We will try and find out when we're next going to have a bunch of these available because they are pretty cool t-shirts. So yeah. Well, thank you very much, everybody.
Thanks,
you,
everyone.
Matt.
And check
Thank you,
out
everyone.
Francois's client capabilities tool.
Thank you. Appreciate the plug. Thank you, guys. Cheers.